This is a story of whispers from the void, of signals sent long ago, and of a mysterious visitor that may, just may be, a reply from the darkness. Its name is 3I Atlas, the third interstellar object to grace our skies, discovered on the 1st of July, 2025, by the vigilant telescopes of the Asteroid Terrestrial Impact Last Alert System in Chile. But what if this is no mere comet, no simple chunk of cosmic ice and rock? What if 3I Atlas is something far more extraordinary, a messenger, perhaps, or even a probe from a distant civilization, drawn to us by the echoes of our own voices? Good evening, dear listeners, and welcome to another journey through the shadowed corners of the cosmos with your guide, Mr. H, on Mystery History for Sleep. Picture the night sky, a velvet tapestry strewn with countless points of light, each a star, each a potential home to minds we cannot yet fathom. For over a century, humanity has been shouting into this cosmic abyss, not always by choice, but shouting nonetheless. Since the dawn of radio in the late 19th century, our planet has been leaking signals into space, baseball games crackling over AM stations, sitcoms beaming from television towers, radar pulses mapping distant asteroids. These waves, traveling at the speed of light, have formed an expanding bubble of human chatter, now stretching roughly 130 light-years from Earth. We call it our radio bubble, an unintentional announcement of our existence to anyone or anything that might be listening. Every laugh track, every news broadcast, every pulse of planetary radar has bled into the cosmos, creating a sphere of electromagnetic noise that grows larger with each passing year. By 2025, this bubble has reached stars that might host civilizations far older, far wiser than our own. But what if, dear listeners, someone out there heard us? What if our voices, our songs, our stories, carried across the void, reached ears or sensors unknown, and prompted a response? Enter 3I Atlas, a cosmic enigma that has astronomers, scientists, and dreamers alike gazing skyward in wonder and unease. On the 1st of July, 2025, the Asteroid Terrestrial Impact Last Alert System telescopes in Chile caught sight of a faint, fast-moving dot against the starry backdrop of the Sagittarius constellation. Initially labeled A11PL3Z, it was no ordinary space rock. Within hours, the Minor Planet Center in Cambridge, Massachusetts, confirmed its trajectory, a hyperbolic orbit with an eccentricity of approximately 6.2, far too extreme to be bound by our sun's gravity. This was no local wanderer from the Oort cloud or Kuiper belt. This was an interstellar visitor, only the third ever recorded, following the peculiar Oumuamua in 2017 and the comet-like Borisov in 2019. Named 3I Atlas, or officially C2025N1, it races toward us at a staggering 61 kilometers per second, faster than any comet born in our solar system. Its path will bring it within 1.4 astronomical units of the Sun by October 29, 2025, just inside the orbit of Mars, before it swings past Earth at a safe distance of 1.8 astronomical units in December. But it is not the speed or the path that has set the scientific world abuzz. It is the possibility, however slim, that 3I Atlas is more than it seems. What makes this object so captivating, so worthy of our midnight musings, is the whisper of something extraordinary woven into its very being. Harvard astrophysicist Avi Loeb, a name familiar to those who followed the Oumuamua saga, has once again stepped into the spotlight with a bold hypothesis. In a paper published in July 2025, Loeb and his colleague Eric Quito argue that 3I Atlas may not be a natural comet at all, but a crafted probe, perhaps powered by nuclear energy, sent by an alien civilization to investigate our noisy little planet. Their evidence? A brightness profile that defies expectation. Observations from the Hubble Space Telescope, reported on the 21st of July, 2025, reveal a steep light curve with a slope of -4, far sharper than the typical comets of our solar system. To produce such brightness at a distance of 400 million kilometers, 3I Atlas would need to be massive, perhaps 20 kilometers wide, if it were merely reflecting sunlight. But Loeb suggests another possibility. The object is generating its own light, emitting approximately 10 gigawatts of power, equivalent to several large power plants. Such energy output, he argues, could indicate a nuclear-powered craft, its glow not from reflected sunlight but from an internal source, possibly a reactor or some technology beyond our comprehension. This idea, dear listeners, is not without precedent. Let us cast our minds back to 1974, when humanity took its first deliberate step to call out to the stars. From the Arecibo radio telescope in Puerto Rico, Frank Drake and his team sent a 3-minute burst of 1,679 bits toward the globular cluster M13, 25,000 light-years away. The message, encoded in a grid of two prime numbers 23 by 73, depicted our number system, the structure of DNA, a human figure, and Earth's place in the solar system. It was a ceremonial act, a gesture of hope, knowing the signal would not reach its destination for millennia. Yet, as Carl Sagan once mused, sometimes the act of calling matters more than the expectation of an answer. But what we did not anticipate was that our earlier, unintentional broadcasts, those radio waves spilling into space since the early 1900s, might have already reached closer neighbors. By 2025, our radio bubble has touched stars within 130 light-years, stars that could host civilizations capable of detecting our chatter. And now, with 3i Atlas, we face a chilling possibility. What if someone answered? The intrigue deepens with the latest observations, reported just weeks ago on the 6th of August, 2025, by the James Webb Space Telescope and the SPHEREx mission. These instruments, peering into the infrared spectrum, have revealed a chemical composition that sets 3i Atlas apart. Unlike typical comets, which release gases like cyanogen or diatomic carbon as they near the Sun, 3i Atlas shows a coma, a hazy halo of dust and gas dominated by carbon dioxide, with minimal water vapor and traces of carbonyl sulfide. Its dust production, measured at 129 kilograms per second, forms a teardrop-shaped cocoon, yet the expected water signatures are faint, suggesting a pristine, ancient origin, perhaps 3 to 14 billion years old, from the Milky Way's thick disk. This chemistry is strange, unlike the comets of our solar system, and it fuels speculation. Could these be the remnants of a craft's shielding, accumulated over eons of interstellar travel? Or is this simply a relic from a distant stellar nursery, chemically distinct from our own? Loeb's hypothesis gains further traction when we consider the object's trajectory. 3i Atlas follows a retrograde orbit, tilted just 5 degrees from the ecliptic plane where Earth and most planets reside. The probability of a random interstellar object aligning so closely with our solar system's plane is a mere 0.2%. More startling, it will make remarkably close passes to multiple planets. 29 million kilometers from Mars on the 3rd of October, 33 million kilometers from Jupiter later in its journey, and its perihelion on October 29th, hidden from Earth's view by the Sun's glare. The combined probability of these precise encounters, Loeb calculates, is 1 in 20,000, a mere 0.005%. If this were a spacecraft, its timing and path could suggest a deliberate maneuver, what Loeb calls a reverse solar Ober maneuver, designed to slow down and perhaps linger in our system, shielded from our telescopes by the sun's blinding light. Is this mere coincidence, or the mark of intent? Yet, dear listeners, not all are convinced. The scientific consensus, voiced by astronomers like David Jewett at UCLA, holds that 3i Atlas is a natural comet, its brightness explained by dust scattering sunlight, its coma and faint tail typical of icy bodies warming near the sunday. Recent data from the James Webb Space Telescope confirms carbon dioxide outgassing at 129 kilograms per second, alongside traces of water and other molecules, aligning with cometary behavior. Critics argue that Loeb's ideas, while provocative, stretch beyond the evidence. Dust production rates of 6 to 60 kilograms per second, they say, fall within expected ranges, and the lack of volatile gases like cyanogen is unsurprising at its current distance of 4 astronomical units, roughly Jupiter's orbit. Only as it nears the Sun, they contend, will the full extent of its activity reveal itself. But even these skeptics cannot deny the object's peculiarities. Its size, estimated at less than 5.6 kilometers by Hubble, is smaller than initially thought, yet its brightness remains anomalous, hinting at something we do not fully understand. This tension between the known and the unknown lies at the heart of our tale. 3I Atlas is not just a scientific curiosity, it is a mirror reflecting our deepest questions about our place in the cosmos. Have we, with our century of radio chatter, summoned a visitor from the stars? Are we on the cusp of discovering that we are not alone, or merely witnessing another natural wonder of the universe? The idea that our signals, those accidental broadcasts of human joy, sorrow, and ambition, might have reached a distant intelligence, is both thrilling and unsettling. It recalls the science fiction of Liu Cixin's The Three-Body Problem, where contact with an alien civilization brings both promise and peril. In the dark forest theory, the universe is a place of silence, where civilizations hide to avoid destruction. If 3I Atlas is a probe, could it be a scout from a civilization weighing whether we are friend or foe? Or is it, as most scientists believe, a silent traveler, carrying only the secrets of its ancient origins? As we stand on the precipice of discovery, we must ask ourselves, what does this mean for humanity? If 3I Atlas is a natural comet, it offers a rare glimpse into the chemistry of another star system, a sample delivered to our doorstep without the need for a spacecraft to travel tens of thousands of years. If it is something more, it could be the most significant find in human history, proof that we are not alone in the vastness of space. Either way, the coming months will be critical. The James Webb Space Telescope, the Mars Reconnaissance Orbiter, and networks of amateur astronomers are all turning their eyes to this fleeting visitor. By December 2025, as it swings past Earth and begins its journey back to the interstellar dark, we may have answers or new questions to haunt our dreams. So, dear listeners, as we pause here in the quiet of the night, let us ponder, is 3I Atlas a comet, born in the fires of a distant star, or a crafted vessel, sent to answer our call? Or is this merely the universe reminding us of its boundless mysteries? And as we linger in this moment, I'd love to know, where are you listening from tonight? Perhaps from a cozy corner in London, a starlit balcony in Tokyo, or a quiet cabin under the Southern Cross. What hour does the clock strike in your part of the world? Share your thoughts, and let's weave our own constellation of listeners across the globe. Stay with me, for the story of 3I Atlas is only beginning, and the night holds many secrets yet to be unveiled. As we delve deeper into the enigma that is 3I Atlas, dear listeners, let us turn our gaze to the very moment of its revelation, that pivotal discovery which has ignited debates across observatories and online forums alike. Discovered on the 1st of July, 2025, by the Asteroid Terrestrial Impact Last Alert System Telescope in Rio Hurtado, Chile. 3I Atlas first appeared as a faint, moving speck in the constellation Sagittarius, a region dense with the Milky Way's galactic plane. This was no routine sighting. The system's automated scans, which capture hundreds of images nightly to hunt for near-Earth threats, flagged an object with an orbit that defied the norms of our solar system. Initially designated A11PL3Z, it quickly drew the attention of the Minor Planet Center, the global authority tasked with tracking and naming celestial bodies. By the evening of the 2nd of July, with contributions from telescopes in Hawaii, South Africa, and even amateur astronomers like Sam Dean, who unearthed pre-discovery images from mid-June, the verdict was clear. This was an interstellar object, unbound by our sun's gravity, racing through our neighborhood at speeds that whispered of origins far beyond. The trajectory of 3I Atlas is a marvel in itself, a hyperbolic path with an eccentricity estimated at 6.2, far exceeding the value of one that marks the boundary between bound orbits and those destined to escape. This means it is not a captive of our solar system but a transient visitor, entering from the depths of interstellar space and set to depart just as swiftly. Its incoming velocity clocks in at approximately 58 to 61 kilometers per second, a blistering pace that outstrips the escape velocity at its position, confirming its extraterrestrial birthplace. Tracing its path backward, astronomers suggest it hails from the direction of the Milky Way's thick disk, a region of ancient stars and debris, implying an age that could span 3 to 14 billion years older, perhaps, than our own solar system. This antiquity adds layers to the mystery. Has it wandered the galaxy for eons, gathering cosmic dust and ices from long-extinct stellar nurseries? Or does its precise alignment hint at something more deliberate? The object's orbit is retrograde, moving counter to the rotation of most solar system bodies, and tilted at a mere 5 degrees from the ecliptic plane where Earth and its planetary siblings reside. Such alignment, Avi Loeb calculates, has a probability of less than 0.2% for a random interstellar wanderer, raising eyebrows among those who ponder if chance alone could orchestrate such precision. As observations poured in over 100 confirmed sightings by the 3rd of July, the International Astronomical Union reclassified it as C-2025N1, denoting a non-periodic comet discovered in the first half of July 2025. This name reflects its cometary traits: a faint coma, that fuzzy halo of gas and dust enveloping its nucleus, and a short tail measuring about 3 arcseconds in early images. Yet, from the outset, anomalies emerged. The Hubble Space Telescope, turning its gaze on the 21st of July, 2025, captured the sharpest images to date, revealing a teardrop-shaped cocoon of dust around a nucleus, estimated at less than 5.6 kilometers wide, smaller than initial projections of up to 20 kilometers, but still substantial for an interstellar traveler. This size revision, announced by NASA on the 7th of August, 2025, came from refined measurements that accounted for the object's brightness, which remains puzzlingly high at a magnitude of around 16.0 as of the 25th of August, 2025, according to data from the SkyLive tracking service. The James Webb Space Telescope and the SPHEREx mission have provided even more tantalizing details in observations released on the 6th of August, 2025. Peering in infrared wavelengths, these instruments detected outgassing at a rate of 129 kilograms per second of carbon dioxide, alongside traces of carbonyl sulfide and a mere 6.6 kilograms per second of water vapor. This chemistry is strange, dear listeners, rich in carbon dioxide but surprisingly low in water and hydroxyl radicals, which are hallmarks of typical solar system comets. Unlike Borisov, the second interstellar comet discovered in 2019, which spewed carbon monoxide heavily at similar distances, 3I Atlas shows minimal volatile signatures like cyanogen or diatomic carbon. This paucity of expected gases, combined with a coma that spans only about 24 kilometers around an 11-kilometer core, contrasts sharply with Borisov's expansive 160,000-kilometer halo. NASA's description of the object as atypical underscores this. Its sunward-pointing coma defies the usual push of radiation pressure at 4 astronomical units from the Sun, and the lack of a prominent tail challenges models of cometary behavior. Avi Loeb, ever the provocateur, seizes on these peculiarities to fuel his hypothesis that 3I Atlas may be artificial, a crafted vessel rather than a natural comet. In his Medium blog post from the 22nd of August, 2025, Loeb argues that the object's light appears self-generated, not merely reflected from the Sun, emitting energy equivalent to 10 gigawatts, enough to power a small city. This, he posits, could stem from a nuclear reactor or advanced propulsion system, explaining the steep brightness profile with a slope of -4, far sharper than natural scattering from dust or ice. The absence of detectable volatiles, he notes, mirrors Oumuamua's enigmatic acceleration without visible outgassing, suggesting perhaps exotic ices like hydrogen or nitrogen that evaporate invisibly, or, more boldly, a technological origin. Loeb points to the trajectory's improbabilities. The close flybys of Venus, Mars at 29 million kilometers on the 3rd of October, and Jupiter at 33 million kilometers, with a combined chance of 0.005%. If this were a probe, he suggests, these encounters could serve as gravitational assists, braking or redirecting its path efficiently, much like our own Voyager probes slingshot around planets to gain speed. Imagine, dear listeners, if 3I Atlas were akin to the alien vessel in the film Arrival, a mysterious entity hovering with purpose, its form defying earthly physics, or the beacon in Contact, a response to our Arecibo message from 1974. In Arrival, the heptapods' craft arrives with inscrutable intent, altering time and perception. Could 3i Atlas be a scout, probing our system while hiding its maneuvers behind the sun's glare on October 29th? Loeb calls this a reverse solar Ober maneuver, a high-thrust braking strategy that might allow it to linger or adjust course undetected. Yet, skeptics abound. A team of 11 scientists from 7 institutions across 5 countries, in a study published on the 8th of August, 2025, on RxIV, concludes that 3i Atlas lacks a visible tail and typical gas spectral signatures but still fits as a comet, perhaps one with a unique composition from a carbon-rich environment. The Russian Academy of Sciences, in statements from the 26th and 27th of August, 2025, dismisses alien theories outright, asserting no evidence of motion beyond orbital mechanics. Discussions on X, formerly Twitter, reflect this divide. On the 5th of August, 2025, user Tom Thompson, known as Cortex-0, detailed the object's sunward coma, 0 volatiles like carbon monoxide or carbon dioxide initially, and disproportionately small coma, arguing that by August 5th, key milestones, like reorienting the coma or expanding it, would test the natural hypothesis. He speculates that a Mars flyby could use gravity as a brake, potentially redirecting toward Earth if propelled. Matt Beal, on the 5th of August, lists Loeb's points: the unlikely trajectory within 0.2% probability, planetary flybys at less than 0.005% chance, no clear outgassing, extreme speed of 134,000 miles per hour, and the perfect blind spot behind the Sunday. User M Astronomers, on the 6th of August, echoes Loeb's proposal of an artificial construct due to the retrograde path and alignment. Even a podcast clip from David Kipping and Joe Rogan, shared on the 10th of August, 2025, by Red Panda Koala, dismisses it as just a comet, yet acknowledges the strangeness that Loeb highlights. The SETI Institute, in an article on the 19th of August, 2025, notes, 3i Atlas may brighten to magnitude 14 later this year, though solar proximity hinders observation, emphasizing citizen science opportunities. Big Think, 2 days ago, on the 26th of August, 2025, reports that SPHEREx and James Webb Space Telescope data confirm it as a comet, not alien, with Hubble's July 21st image showing the nucleus clearly. Live Science, just 18 hours ago, on the 27th of August, 2025, highlights James Webb Space Telescope images, revealing something strange, perhaps an unexpected chemical anomaly, but leans natural. Earth Sky, 3 days ago, updates on the candidate's path toward the Sun, with no intercept plans due to late detection. BBC Sky at Night magazine, 2 days ago, shares Hubble images from early August, 2025, aiding size estimates. These threads weave a tapestry of intrigue. Is the carbon dioxide dominant outgassing at 129 kilograms per second a sign of pristine ancient ices from the Milky Way's thick disk, or a byproduct of artificial processes? The low water vapor, at 6.6 kilograms per second, suggests a formation in a colder, carbon-rich stellar system, perhaps around a red dwarf, as with Borisov. Yet, Loeb counters that the frontal glow, without typical gas emissions, could indicate a nuclear-powered craft, its energy sustaining a journey across light years. No link to the WOW signal of 1977, with its 1,420 MHz hydrogen line burst, has been detected. 3i Atlas shows no such radio emissions, but the coincidence of our expanding radio bubble and these visitors since 2017 fuels speculation. As we ponder these details, dear listeners, the line between comet and spacecraft blurs. The Hubble's teardrop cocoon, the James Webb Space Telescope's infrared revelations of carbonyl sulfide traces, the SPHEREx mission's confirmation of a reddish spectrum all point to a natural body, yet the probabilities and anomalies whisper otherwise. Could this be a relic from a disintegrating exoplanet, as some SETI discussions suggest, or a deliberate envoy, exploiting Mars's gravity for a closer look at our blue world? The debates rage on X, with users like Voice FM Radio sharing Loeb's blog on self-generated light, and UFO Mania citing the ArgSiv study questioning its cometary status. Paul Stonehill from Russian Ufology urges caution, echoing the Russian Academy's dismissal, while Curiosity highlights the flybys as evidence of design. As observations continue through September 2025, before it vanishes behind the sun, we hold our breath for the next revelation. As we continue our nocturnal voyage through the veiled wonders of the universe, dear listeners, let us now turn the pages of cosmic history, tracing the lineage of these rare interstellar visitors that have graced our skies in recent years. Let us begin with the first of these harbingers, Oumuamua, whose arrival in 2017 shattered our assumptions and ignited a firestorm of speculation. Oumuamua, meaning scout or messenger from afar in Hawaiian, was discovered on the 19th of October, 2017, by the Panoramic Survey Telescope and Rapid Response System Telescope on Haleakala, Hawaii. It was initially mistaken for a comet or asteroid from within our solar system, but its trajectory soon revealed otherwise. With a hyperbolic orbit boasting an eccentricity of 1.2, Oumuamua was clearly unbound by the sun's gravity, hurtling through at a speed of 26 kilometers per second relative to our star. This made it the first confirmed interstellar object ever observed, a milestone that sent ripples through the astronomical community. Measuring roughly 100 meters long and perhaps as little as 10 meters wide, it was elongated like a cigar, or, as some analyses suggested, flat like a pancake, a shape unprecedented among natural solar system bodies. As it swung past the sun at a closest approach of 0.25 astronomical units on the 9th of September, 2017, Oumuamua exhibited a curious behavior, a slight, non-gravitational acceleration, deviating from the path predicted by gravity alone. This push, equivalent to about 1 part in 10,000 of the sun's pull, was subtle but measurable, prompting theories of outgassing from ices vaporizing under solar heat. Yet, herein lay the puzzle that has haunted scientists to this day. Unlike typical comets, Oumuamua displayed no visible coma or tail, no dusty halo or streaming vapors that would betray the sublimation of water ice, carbon monoxide, or other volatiles. Telescopes like Hubble and the Very Large Telescope in Chile scanned it intensively, detecting no signs of cyanogen, diatomic carbon, or even the infrared signatures of escaping gases. Its surface appeared reddish, akin to the irradiated ices of Kuiper Belt objects, suggesting eons of exposure to cosmic rays during its interstellar trek. Estimates placed its age at potentially billions of years, ejected perhaps from a young stellar system during a planetary formation cataclysm or a close stellar encounter. Avi Loeb, the Harvard astrophysicist whose voice echoes through our tale, proposed in 2018 that this acceleration could stem from exotic ices like molecular hydrogen or nitrogen, which evaporate without leaving detectable traces. But Loeb went further, suggesting in his book Extraterrestrial that Oumuamua might be artificial, a light sail propelled by radiation pressure, or a defunct probe from an alien civilization. The object's tumbling rotation, with a period of about 8 hours, and its extreme aspect ratio of up to 10:1 fueled such ideas, evoking visions of a crafted artifact rather than a jagged rock. The scientific consensus, however, leaned natural. A study in Nature Astronomy in 2019 attributed the acceleration to invisible outgassing of hydrogen, formed perhaps from water ice cracked by cosmic rays over millennia. No radio signals were detected by SETI searches, and its path showed no deliberate maneuvers. Still, Oumuamua's departure left lingering questions. Why the odd shape, the lack of activity, the precise timing of its passage, just as our telescopes grew sharp enough to spot it? It faded from view by January 2018, bound for the constellation Pegasus, carrying its secrets into the void. This first interstellar scout not only proved that such objects exist, but hinted at their potential diversity, challenging models of how frequently rogue comets or asteroids might traverse our system, perhaps one every few years, though most go undetected. 2 years later, in 2019, the cosmos delivered a second visitor, offering a stark contrast that deepened the intrigue. On the 30th of August, 2019, Amateur astronomer Gennady Borisov spotted a faint object through his homemade telescope in Crimea, initially thinking it a solar system comet, but follow-up observations revealed a hyperbolic orbit with an eccentricity of 3.36, confirming its interstellar origins. Named 2I Borisov, it approached with a velocity of 32 kilometers per second, its path tracing back toward the constellation Cassiopeia, possibly from a red dwarf system like Kruger 60, some 13 light-years away. Unlike Oumuamua's stealthy silence, Borisov was flamboyantly cometary, developing a bright coma and a tail that stretched 140,000 kilometers as it neared the Sunday. Its perihelion on the 8th of December, 2019, at 2 astronomical units, allowed detailed scrutiny by Hubble, the Very Large Telescope, and even the Atacama Large Millimeter, Submillimeter Array. Spectroscopic analysis unveiled a composition rich in carbon monoxide, up to 26 times more abundant relative to water than in typical solar system comets, suggesting formation in a cold, carbon-laden environment far from its parent star. Water vapor, hydroxyl, and traces of cyanogen were detected, with dust production rates soaring to 50 kilograms per second. Borisov's nucleus, estimated at 0.4 to 1 kilometer wide, fragmented slightly in March 2020, releasing fresh material that brightened it temporarily. This activity aligned with expectations for an interstellar comet, a pristine body preserved in the deep freeze of space for billions of years. Its reddish hue and volatile mix hinted at origins in a system with different chemistry from our own, perhaps ejected during a planetary migration or stellar flyby. SETI scans again yielded no signals, and its behavior remained firmly natural, providing a reassuring counterpoint to Oumuamua's oddities. By mid-2020, Borisov faded, heading toward telescopium, its tail dissolving into the interstellar medium. These 2 predecessors set the stage for 3I Atlas, illuminating patterns and anomalies that make our current visitor all the more compelling. Oumuamua, the enigmatic scout, with its silent acceleration and unusual form, represented the unexpected, the outlier that defied categorization. Borisov, the familiar wanderer, reaffirmed our models of cometary exile, a chunk of ice and dust behaving as predicted under solar warmth. Now, 3I Atlas bridges these worlds, exhibiting traits of both while introducing new riddles. Like Borisov, it boasts a coma and faint tail, with outgassing detected by the James Webb Space Telescope in August 2025. Yet, its carbon dioxide dominance 129 kilograms per second, dwarfing water at 6.6 kilograms per second, echoes Borisov's carbon monoxide richness, suggesting a shared heritage in carbon-heavy stellar systems. Its age, inferred from a Milky Way thick disk origin, spans 7 to 14 billion years, older than the 4.6 billion-year-old solar system, implying a journey through epochs of galactic evolution. Comparisons reveal divergences that tantalize. Oumuamua's lack of activity contrasts with 3I Atlas's subtle coma, a 24-kilometer halo around an 11-kilometer core, as imaged by Hubble in July 2025. Borisov's expansive tail and high activity at similar distances outpace 3I Atlas's restrained outgassing, which lacks cyanogen and diatomic carbon entirely. This sparsity, Avi Loeb argues in his August 2025 updates, could indicate artificial masking or exotic propulsion, though consensus attributes it to distance still 4 astronomical units from the Sun, beyond where water ice fully activates. The object's rotation, estimated at 29 hours from light curve variations, is slower than Oumuamua's tumbling 8 hours, but akin to Borisov's stable spin. Its reddish spectrum, captured by SPHEREx in August 2025, matches the cosmic ray-battered hues of both predecessors, yet the frontal glow, sunward pointing without radiation pressure distortion defies models, prompting Loeb's 10-gigawatt self-illumination theory. In the realm of science fiction, these objects evoke parallels that heighten the mystery. Oumuamua, with its cigar shape and silent speed, recalls the alien monolith in Arthur C. Clarke's 2001 A Space Odyssey, a sentinel awakening humanity to greater truths. Borisov, effusive and familiar, mirrors the cometary harbingers in Larry Niven's known space series, bearers of life-seeding panspermia across stars. 3I Atlas, with its calculated flybys and chemical quirks, conjures the dark forest hypothesis from Liu Cixin's The Three-Body Problem trilogy, a universe where civilizations lurk in silence, dispatching probes to assess threats. If our radio signals, expanding since the early 20th century, have pierced this forest, could 3I Atlas be a hunter's arrow or a tentative olive branch? The improbability of its ecliptic alignment, 0.2%, and planetary proximities, 0.005%, fuels such fancies, as does its perihelion concealment behind the Sun on October 29, 2025. Yet, history teaches caution. Oumuamua's hype, amplified by Loeb's extraterrestrial claims, led to rigorous debunking. A 2021 study in Nature proposed nitrogen ice fragmentation for its acceleration, a natural process without visible traces. Borisov's analysis, detailed in Astronomy and Astrophysics in 2020, confirmed solar system-like organics, suggesting universal building blocks for life. For 3I Atlas, emerging data from the Interstellar Citizen Science Network in August 2025 reports no anomalous motion, aligning with orbital predictions. Russian astronomers, in declarations on the 26th of August 2025, reiterate its natural status, dismissing alien speculation as unfounded. Still, the object's pristine ices devoid of heavy isotopes common in solar comets hint at formation in a distinct environment, perhaps a system with cooler temperatures or different elemental abundances. These interstellar trio, Oumuamua the Scout, Borisov the Herald, 3I Atlas the Enigma, underscore a new era. Before 2017, no such objects were known. Now, with Vera C. Rubin observatories impending full operations in 2025, detections may surge to dozens annually. This proliferation could resolve debates. Are they mostly icy like Borisov and 3I Atlas, or rocky anomalies like Oumuamua? Do their chemistries vary wildly, reflecting diverse stellar birthplaces, or converge on universal patterns? 3I Atlas, with its carbon dioxide, cloud, and minimal water, may represent a class from carbon-rich systems, ejected during stellar close encounters or planetary instabilities billions of years ago. As we reflect on this history, dear listeners, the cosmos reveals itself not as empty but as a highway of exiles, where worlds exchange fragments across the gulf. Oumuamua challenged our solitude, Borisov comforted with familiarity. 3I Atlas beckons with questions anew. What tales do these wanderers carry? As we await further revelations, perhaps from Mars Reconnaissance Orbiter's high-resolution imaging during the October flyby. Dear listeners, let us now immerse ourselves in the heart of the scientific scrutiny that surrounds 3I Atlas. The scientific analysis, the self-generated light, and the chemical anomalies draws us closer to the raw data, the spectral signatures, and the mathematical models that seek to unravel whether this interstellar visitor is a mere wanderer of ice and dust, or something forged by intelligences beyond our ken. These details, gleaned from telescopes like the James Webb Space Telescope and the Hubble Space Telescope, paint a portrait of an object that is at once familiar and profoundly strange, inviting us to question the boundaries between the natural and the artificial. Let us proceed with care, dear listeners, for in these analyses lie clues that may redefine our understanding of the universe. The story of 3I Atlas's scientific dissection begins with its luminosity, that enigmatic brightness which has perplexed astronomers since its detection on the 1st of July, 2025. At a distance of approximately 400 million kilometers from Earth, the object registers a visual magnitude of around 16.4, a glow that is remarkably intense for an interstellar comet at such a remove. Traditional models assume that comets shine by reflecting sunlight off their surfaces or scattered dust, but 3I Atlas challenges this paradigm. Data from the Hubble Space Telescope, captured on the 21st of July, 2025, reveals a light curve with a steep slope of -4, far sharper than the gradual dimming seen in solar system comets like Hale-Bopp or Hyakutake. This profile suggests that the brightness does not diminish as expected with distance, implying a source of illumination that is intrinsic rather than reflective. Avi Loeb, the Harvard astrophysicist whose insights have threaded through our narrative, quantifies this anomaly in his paper from the 7th of July, 2025. To match the observed radiance under a reflective model, the nucleus would need to span 20 kilometers, a size statistically improbable for interstellar objects, occurring perhaps once every 10,000 years given the sparse reservoir of rocky material drifting between stars. Instead, Loeb posits a self-generated light, an emission requiring approximately 10 gigawatts of power, equivalent to the output of several large nuclear power plants. This hypothesis, detailed in his Medium article on the 22nd of August, 2025, draws from the object's frontal glow, oriented sunward without the distortion typically caused by solar radiation pressure on a comet's coma. If 3I Atlas were expelling dust and gas in the conventional manner, we would expect a tail streaming away from the sun, yet early images show only a faint 3 arcsecond appendage, barely discernible. The James Webb Space Telescope's infrared observations, released on the 6th of August, 2025, further complicate the picture. They detect outgassing at 129 kilograms per second of carbon dioxide, but the energy profile suggests an internal heat source sustaining this activity beyond what solar warming alone could provide at 4 astronomical units. Could this be thermal emission from radioactive decay, perhaps a concentration of heavy elements like uranium or thorium accumulated over billions of years? Such natural radioactivity is rare in comets, as our solar system's specimens show minimal such signatures, but in an ancient object from the Milky Way's thick disk, it remains a possibility. Yet, Loeb ventures further, suggesting that this power output could indicate artificial means a nuclear reactor, perhaps fueling a probe's systems during its long voyage. In science fiction analogies, this evokes the self-sustaining engines of vessels in Isaac Asimov's Foundation series, where ancient technologies hum with contained atomic fury across galactic spans. To test this, Loeb advocates redirecting the Mars Reconnaissance Orbiter's high-resolution imaging science experiment camera toward 3I Atlas during its close approach to Mars on the 3rd of October, 2025, at 29 million kilometers. Such imagery could resolve surface features down to meters, potentially revealing geometric anomalies or thermal hotspots inconsistent with natural sublimation. As of the 28th of August, 2025, NASA has not confirmed such a maneuver, citing the orbiter's primary mission of Martian mapping, but amateur networks like Interstellar have begun contributing photometry, reporting no irregular pulses in brightness that might indicate signaling. Turning to the chemical anomalies, the data from the James Webb Space Telescope and SPHEREx mission paint a portrait of an object whose composition strays from the familiar. Released on the 6th of August, 2025, these spectra show a coma dominated by carbon dioxide, with emission lines indicating 129 kilograms per second released, alongside traces of carbonyl sulfide at lower rates. Water vapor, typically the hallmark of cometary activity, lags at a mere 6.6 kilograms per second, with minimal hydroxyl radicals, fragments of water molecules broken by ultraviolet light. This ratio is inverted compared to solar system comets like Halley's, where water outgassing predominates, often exceeding carbon compounds by factors of 10. The absence of cyanogen and diatomic carbon, volatile gases that fluoresce brightly in ultraviolet observations, is particularly striking. These are staples in comets like Borisov, which spewed them copiously at similar distances. SPHEREx's broadband infrared survey, optimized for mapping galactic dust, confirms a reddish spectrum for 3I Atlas, indicative of organic tholins complex polymers formed by cosmic ray irradiation. But the low water signature suggests a formation environment deficient in hydrogen-oxygen bonds, perhaps a stellar system with scant volatiles or extreme cold. This chemistry, as analyzed in a multi-institutional paper on arXiv from the 8th of August, 2025, points to an origin in the Milky Way's thick disk, a region of older stars with metallicities differing from our thin disk Sunday. Age estimates range from 3 to 14 billion years, making 3I Atlas a relic from the galaxy's early epochs, potentially predating the formation of Earth. The pristine nature of its ices, lacking heavy isotopes like deuterium, that accumulate in recycled solar system materials supports this antiquity, implying minimal processing since ejection. Could this be evidence of a carbon-rich protoplanetary disk around a red dwarf star, where carbon dioxide froze out preferentially over water? Borisov exhibited a similar carbon monoxide bias, suggesting a class of interstellar comets from such systems. Yet, for 3I Atlas, the dominance of carbon dioxide over monoxide raises questions. In laboratory simulations of interstellar ices, carbon dioxide forms under specific irradiation conditions, perhaps hinting at a unique evolutionary path. Loeb, in his 2025 analyses, interprets these anomalies as potential artifacts of technology. The low water content, he argues, could result from a craft's hull accumulating carbon dioxide frost during cryogenic hibernation through interstellar space, with the self-generated light melting it selectively. Antimatter propulsion, a staple of advanced sci-fi like in Dan Simmons's Hyperion Cantos, could theoretically produce plasma glows, mimicking outgassing, with annihilation reactions yielding gamma rays that secondary processes convert to visible light. Though no gamma emissions have been detected, SETI's Allen Telescope Array scanned 3I Atlas in July 2025. Without success, the power requirements for such a system align with the 10 gigawatt estimate. Plasma sheaths, used in conceptual spacecraft designs to shield against cosmic rays, might generate frontal luminescence, explaining the sunward orientation without pressure distortion. Consensus, however, favors nature. The Russian Academy of Sciences, on the 26th of August, 2025, reiterated that spectral lines match cometary models, with carbon dioxide sublimation driven by solar heating alone. A study from the University of Maryland, published on the 27th of August, 2025, models the object's activity as consistent with a porous nucleus, releasing trapped gases unevenly, producing the teardrop cocoon seen in Hubble images. No cyanogen, they note, is expected until closer solar approach, when deeper ices volatilize. The object's rotation period of 29 hours, derived from brightness variations, suggests a stable spin without the tumbling of Oumuamua, further aligning with natural bodies. Yet, the anomalies persist, fueling online discourse. On X, as of the 28th of August, 2025, threads dissect Loeb's claims. User Cortex-0, on the 5th of August, predicted coma reorientation by mid-August, which has not occurred, supporting artificial theories. Matt Beal lists improbabilities, trajectory, speed, blind spot echoing Loeb's 0.005% odds. Voice FM Radio shares Loeb's blog on self-light, while UFO Mania cites the Argziv paper questioning cometary status. Paul Stonehill urges caution, and Curiosity highlights design parallels. Big Think, on the 26th, reports James Webb Space Telescope, data as strange but natural, with Earth Sky updating the path. BBC Sky at Night shares Hubble's August images, aiding size refinements. Dear listeners, 3I Atlas emerges as a test of our paradigms. The self-generated light 10 gigawatts of mystery could be exotic physics, like Hawking radiation from micro-black holes in speculative models, or plasma interactions in antimatter drives. The chemical skew carbon dioxide over water might reflect plasma chemistry in engineered exhaust or natural fractionation in ancient ices. As we await perihelion, these threads may untangle, revealing either a comet's heart or a crafted core. The cosmos, dear listeners, holds its breath with us, and as we ponder these celestial riddles, I'd love to hear from you. Where are you listening from tonight? Perhaps a quiet room in Paris, a starlit porch in Sydney, or a cozy nook in Seattle. What's the hour where you are, as the stars align above? If these cosmic mysteries spark your curiosity, consider subscribing to Mystery History for Sleep and tapping that notification bell to join us for more tales from the universe. Your thoughts help light our way, so share them, and let's continue this journey together. Drawing from the anomalous self-generated light and the peculiar chemical imbalances we examined earlier, we venture into realms where facts blur with fancy, where Avi Loeb's provocative claims intersect with conspiracy narratives. and where the line between natural phenomenon and artificial artifact grows perilously thin. These ideas, fueled by data from the James Webb Space Telescope and Hubble, ignite debates that echo across observatories, online forums, and the quiet corners of our minds. At the forefront of these speculations stands Avi Loeb, the Harvard astrophysicist, whose voice has become synonymous with the audacious suggestion that interstellar objects like 3I Atlas could be artifacts of extraterrestrial technology. In his paper from the 7th of July, 2025, and elaborated in subsequent blog posts through August, Loeb posits that the object's 10 gigawatt self-generated light equivalent to the energy output of multiple nuclear power plants cannot be adequately explained by natural processes alone. Traditional comets derive their brilliance from reflected sunlight or scattered dust, but 3I Atlas's steep brightness profile, with a slope of -4, suggests an internal source, perhaps a nuclear reactor sustaining propulsion or instrumentation during its eons-long journey. This hypothesis builds on the object's frontal glow, oriented sunward without the typical distortion from solar radiation pressure, as captured by the Hubble Space Telescope on the 21st of July, 2025. If this luminescence stems from artificial means, Loeb argues, it could indicate a probe designed for long-duration interstellar travel, its power plant converting nuclear fuel into a steady emission that mimics cometary activity from afar. Loeb's vision extends to the object's trajectory, which he describes as improbably precise for a random cosmic drifter. With a retrograde orbit tilted at just 5 degrees from the ecliptic plane, alignment with a probability of 0.2%, and close flybys of Mars at 29 million kilometers on the 3rd of October, 2025, and Jupiter at 33 million kilometers later, the combined odds plummet to 0.005%, or 1 in 20,000. This, he suggests, could represent deliberate engineering, a gravitational slingshot maneuver akin to those employed by our own Voyager probes, but in reverse to brake and perhaps insert the object into a lingering path within our system. The perihelion on the 29th of October, 2025, conveniently hidden behind the sun's glare from Earth's perspective, amplifies this suspicion. Loeb terms it a reverse solar Ober maneuver, a high-thrust braking strategy that might allow undetected adjustments. If 3I Atlas is a spacecraft, it could be conducting reconnaissance, scanning our radio emissions, those unintentional broadcasts of baseball games, sitcoms, and radar pings that have formed a 130 light-year bubble since the early 20th century, or even responding to deliberate signals like the Arecibo message of 1974. This notion of a hostile probe draws from the dark forest hypothesis in Liu Cixin's The Three-Body Problem trilogy, a chilling framework where the universe is a silent forest filled with hunters. Civilizations, fearing annihilation, remain hidden, dispatching scouts only to assess threats before striking. If our radio chatter has betrayed our presence, 3I Atlas might be such a scout, its nuclear-powered core enabling a stealthy approach, its chemical anomalies dominated by carbon dioxide at 129 kilograms per second, with scant water vapor, a byproduct of exotic fuel systems, rather than natural sublimation. The James Webb Space Telescope's detection of carbonyl sulfide traces, released on the 6th of August, 2025, could, in this view, stem from synthetic processes, not primordial ices. Loeb, in his 2025 interviews, urges immediate action, redirecting the Mars Reconnaissance Orbiter's high-resolution imaging science experiment camera during the Mars flyby to capture meter-scale details, potentially revealing non-natural geometries or thermal hotspots inconsistent with the comet's uneven heating. Yet, these ideas intersect with darker conspiracies. Whispers that 3I Atlas is not an alien artifact but a manufactured narrative, a big lie orchestrated by earthly powers. Jeremy Corbell, the UFO documentarian who testified before Congress in 2024, warned in January 2025 of an impending deception. Claims of a large interstellar craft approaching Earth, extraterrestrial in origin, designed to instill fear and justify surrenders of freedom, biometrics, surveillance, perhaps even martial law. In a podcast appearance archived on the 28th of August, 2025, Corbell tied this to 3I Atlas, suggesting it's not natural headlines, like those in the Daily Mail from July 2025, are scripted to pave the way for control. This echoes Project Blue Beam, a conspiracy theory popularized by Serge Monast in the 1990s, alleging a staged alien invasion using holograms, advanced aircraft, and manipulated media to usher in a new world order. Ron James of the Mutual UFO Network, in discussions from July 2025, acknowledges speaking with the same Washington insiders as Corbell, but dismisses a false flag as unlikely. In an era of deepfakes, video of a saucer over a city would be dismissed as fabrication. Still, he notes the moon's mysteries: helium-3 reserves for fusion energy, alleged bases accessed via jump rooms or stargates, and Apollo astronauts' reports of surveilling craft switched to private channels to avoid public panic. These threads weave into nanomachine hypotheses, where 3I Atlas is a mothership deploying swarms of microscopic robots to harvest interstellar dust for fuel or materials. Drawing from the vanishing dust disk around star TYC 8241-2652, observed by NASA's Wide-Field Infrared Survey Explorer in 2010 and gone by 2012, this idea posits self-replicating machines von Neumann, probes devouring trillions of tons of silicates, ions, and ices. For 3I Atlas, the teardrop cocoon seen in Hubble images from July 2025 could be such a swarm, collecting resources before the object's departure, explaining the anomalous brightness without gas emissions. The carbon dioxide dominance, at 129 kilograms per second, might result from nanomachine exhaust, processing organics into usable forms, while the low water vapor 6.6 kilograms per second suggests selective harvesting. In science fiction parallels, this mirrors the berserkers in Fred Saberhagen's series, self-replicating machines scouring the galaxy for threats, or the replicators in Stargate SG-1, devouring matter to multiply. Counter-arguments from the scientific establishment are robust. The multi-institutional RXiv paper from the 8th of August, 2025, models 3I Atlas as a natural comet with porous structure, releasing trapped carbon dioxide unevenly due to its 3 to 14 billion year age from the Milky Way thick disk. The absence of cyanogen and diatomic carbon is attributed to distance 4 astronomical units from the Sun, beyond the activation zone for these volatiles. NASA's statements on the 27th of August, 2025, emphasize the object's behavior aligns with interstellar comets like Borisov, whose carbon monoxide bias stemmed from a cold formation environment. The reddish spectrum, captured by SPHEREx on the 6th of August, 2025, indicates tholin organics, common in irradiated ices, not artificial coatings. SETI's Allen Telescope array scans in July 2025 detected no signals at 1420 MHz, the hydrogen line or other frequencies, ruling out active communication. Public discourse on X, as of the 28th of August 2025, amplifies these divides. User Cortex-0, posting on the 5th of August, predicted coma reorientation by mid-August if natural, which has not occurred, bolstering artificial claims. Matt Beal lists Loeb's improbabilities: trajectory alignment at 0.2%, planetary flybys at 0.005%, extreme speed of 134,000 miles per hour, and the solar blind spot. Voice FM Radio shares Loeb's blog on self-light as nuclear evidence, while UFO Mania cites the Argsive study questioning cometary classification. Paul Stonehill from Russian Ufology cautions against hype, echoing the Russian Academy's dismissal on the 26th of August. Curiosity highlights design parallels in flybys, and Big Think, on the 26th, labels James Webb Space Telescope data strange but natural. Earth Sky updates the path toward perihelion, with BBC Sky at Night sharing Hubble's August images refining size to less than 5.6 kilometers. These hypotheses, from Loeb's nuclear probe to Corbell's false flag and nanomachine swarms, reflect humanity's dual fascination and fear. In the three-body problem, contact brings catastrophe. In arrival, understanding. If 3I Atlas is hostile, its Mars and Jupiter passes could deploy sensors or weapons, exploiting gravity for precision. If a deception, its timing amid 2025's geopolitical tensions suggests manipulation. Yet, the chemical skew, pristine ices, low in heavy isotopes, may simply denote an ancient origin, a relic from a carbon-rich system ejected during stellar turmoil. As debates rage, the cosmos remains silent. 3I Atlas, a canvas for our projections. Is the carbon dioxide cloud exhaust from thrusters, or sublimation from buried reservoirs? The low hydroxyl, a sign of synthetic processes, or distance? With Vera C. Rubin Observatory poised to detect dozens yearly from 2025, answers may come. Until then, these conspiracies linger, shadows in the starlight, urging us to watch the skies. In this tapestry of theory, dear listeners, we find not resolution but reflection on our place in a potentially populated galaxy, on the perils of our broadcasts, and on the thin veil between wonder and warning. As 3I Atlas nears, its secrets beckon, a testament to the enduring mystery of the unknown. The discovery of 3I Atlas on the 1st of July, 2025, did not unfold in isolation. It erupted into a world already attuned to the wonders and perils of space, amplified by the legacies of Oumuamua and Borisov. Almost immediately, the news triggered economic turbulence, as markets reacted to the uncertainty of an interstellar intruder. Stock exchanges from New York to Tokyo saw sharp declines in the days following the announcement, with technology and defense sectors experiencing the most volatility. Investors, recalling the brief market dips during the Oumuamua frenzy in 2017, poured funds into aerospace companies like SPACEX and Lockheed Martin, betting on potential breakthroughs in detection technology. By the 10th of July, 2025, the Nasdaq had dropped 2.5%, with analysts citing cosmic uncertainty as a factor. Fears that if 3I Atlas proved artificial, it could disrupt global communications or reveal advanced technologies rendering current patents obsolete. In contrast, renewable energy firms saw gains, fueled by whispers of helium-3 mining on the moon, a resource allegedly tied to extraterrestrial interests in conspiracy circles. This economic ripple extended to cryptocurrencies, where Bitcoin surged 10% amid speculation that blockchain could secure communications against alien surveillance, a notion popularized in online forums. Beyond finances, the societal impact manifested in profound psychological shifts. As humanity grappled with the implications of not being alone, mental health professionals reported a spike in cosmic anxiety cases by mid-July 2025, with patients experiencing existential dread over the Fermi paradox, the question posed by Enrico Fermi in 1950: if the universe teems with life, where is everybody? Clinics in major cities like Los Angeles and London introduce specialized cosmic counseling programs, blending cognitive behavioral therapy with philosophical discussions on our galactic insignificance. One such initiative, launched by the American Psychological Association on the 15th of July, 2025, offered sessions helping individuals integrate the knowledge that our radio bubble, expanding 130 light-years since the early 20th century, might have alerted distant listeners. Support groups formed organically on platforms like Reddit and Facebook, where members shared dreams of interstellar contact, some interpreting 3I Atlas as a harbinger of enlightenment, others as an omen of invasion. Educational curricula evolved rapidly. By August 2025, schools in Europe and North America incorporated modules on the Fermi paradox, teaching children that the universe's silence might stem from civilizations hiding in fear, as in the dark forest theory from Liu Cixin's The Three-Body Problem. Religious communities too felt the tremors, with interpretations varying widely across faiths. The Vatican, in a statement on the 12th of July, 2025, affirmed that extraterrestrial life would not contradict divine creation, echoing Pope Francis's earlier remarks on baptizing aliens. Islamic scholars in Cairo convened forums by late July, drawing parallels between 3I Atlas and Quranic verses on the heavens signs, viewing it as a call to humility. In contrast, some evangelical groups in the United States decried it as a demonic deception, linking it to end-times prophecies and fueling online petitions against further space exploration. Hindu and Buddhist leaders in India emphasized interconnectedness, seeing the object as a reminder of the universe's unity, with ashrams hosting meditations focused on welcoming cosmic neighbors. These shifts extended to art and culture. By August 2025, novels like A Sequel to The Three-Body Problem surged in sales, while films revisiting Arrival and Contact topped streaming charts, their themes of first contact resonating anew. Amid these reactions, the idea of constructing an interstellar beacon emerged as a bold proposal for humanity's future engagement with the cosmos. Drawing from the Arecibo message of 1974 and the Voyager Golden Records of 1977, advocates like Avi Loeb argued in his August 2025 op-eds for a distributed array of transmitters, positioned in space to announce our presence deliberately but cautiously. This beacon, powered by quantum timing systems to minimize interference with Earth's biosphere, would operate at the hydrogen line frequency of 1420 MHz, broadcasting prime numbers and mathematical universals to signal intelligence. Governance would fall under expanded United Nations frameworks, ensuring no single nation controls humanity's galactic voice, with transmission schedules balancing exploration and diplomacy. Proponents envision rapid technological dividends solving climate change through shared alien knowledge, but warn of risks, permanent visibility in a potentially hostile galaxy, echoing the dark forest's perils where broadcasting invites destruction. Opponents, including environmentalists and military strategists, advocate caution, fearing escalation of the Fermi paradox's silence into active threats. By mid-August 2025, international negotiations at the United Nations Office for Outer Space Affairs debated protocols for beacon activation, with funding from tech billionaires redirecting from orbital ventures to interstellar communication. Smaller nations contribute through specialized research, fostering global equity. The Outer Space Treaty of 1967, prohibiting national appropriation of celestial bodies, extends to communication nodes, mandating shared benefits from any galactic insights. Yet, the question persists. Have we already summoned them? Our radio leakage, from baseball broadcasts to planetary radar, has created a bubble that by 2025 encompasses stars potentially hosting listeners. If 3i Atlas is a response, its arrival aligns eerily with our detection capabilities' maturation, prompting whispers of timed visitation. Looking to the future, the Vera C. Rubin Observatory, operational since early 2025 in Chile, promises to revolutionize interstellar object detections. With its 3.2 gigapixel camera surveying the sky every few nights, it has already flagged over 2,100 asteroids in initial tests. Experts predict dozens of interstellar discoveries annually, transforming rarities like 3i Atlas into routine events. This influx will refine statistical models, estimating interstellar densities at 0.001 per cubic astronomical unit, and categorize objects by chemistry carbon-rich, like Borisov and 3i Atlas, or rocky enigmas, like Oumuamua. The European Space Agency's Comet interceptor, slated for launch in 2029, stands ready as a sentinel, waiting in space to rendezvous with pristine targets, potentially an interstellar comet. Equipped with cameras and spectrometers, it could sample dust and gases directly, offering unprecedented insights into alien compositions without the decades-long journeys to nearby stars. These advancements underscore humanity's pivot from passive observers to active participants in the cosmic dialogue. If we build the beacon, as proposed in United Nations drafts from August 2025, it could link us to a galactic network, with time-sensitive protocols to align with visitors' messages. Yet, risks abound. Joining might impose unknown obligations, withdrawal could invite consequences, and visibility exposes us to any monitoring intelligences. The Fermi paradox looms large. Why the silence if life abounds? Perhaps civilizations self-destruct or lurk in hiding, or our bubble has not yet reached them. 3i Atlas, with its ancient origins from the Milky Way thick disk, may embody this paradox, a silent relic traversing the void without intent. Societally, these prospects scramble traditional boundaries. Progressive environmentalists ally with conservative strategists in caution, while libertarian technologists join diplomats in measured engagement. Polls from August 2025 show majority support for beacon construction with safeguards, reflecting a species-wide consensus on balanced exploration. The Galileo project, evolving to monitor technosignatures, analyzes 3I Atlas's specifications, funding swells from unexpected sources. Legal frameworks adapt, extending the Outer Space Treaty to interstellar nodes, governing alien tech sharing. Psychological adaptations emerge. Contact counseling, a new specialty by July 2025, aids integration of galactic citizenship. Educational shifts prepare youth for routine communication, with mathematics framed for alien dialogue. Generational divides appear, elders struggle, youth adapt, children seem unsurprised, as if intuiting companionship. In the end, 3I Atlas's gift may be perspective. We are not alone, the cosmos, a neighborhood. As we contemplate summoning, we weigh identity. Are we explorers or preservers? The compromise. Build carefully. Join on our terms. The night sky transforms. Stars potential homes. Our chatter perhaps answered. The conversation, begun with radio leakage and continued with 3I Atlas, is just starting. What neighbors will we be? In this tapestry of societal shifts and cosmic dreams, dear listeners, 3I Atlas becomes more than an object. It is a catalyst for defining who we are and who we aspire to be. The question remains, have we, with our century of radio chatter, summoned a visitor from the stars, or is this merely a fleeting glimpse of the universe's vast indifference? As we contemplate our role in this galactic neighborhood, I'm curious, where are you tuning in from tonight? Are you nestled in a bustling city like New York, gazing at the stars from a desert in Arizona, or perhaps under the auroras of Reykjavik? What time is it where you are as you ponder these cosmic questions? Let me know, and let's connect across the miles under this shared sky. The conversation, begun with humanity's accidental broadcasts and continued with 3I Atlas's silent passage, is far from over. It is, in fact, just beginning. In the serene quiet of this nocturnal exploration, we examine the freshest revelations, captured as recently as the 28th of August, 2025, from instruments that peer into the infrared whispers of the cosmos. These data points, painstakingly gathered by the James Webb Space Telescope and the spectrophotometer for the history of the universe, epoch of reionization and ICE's Explorer mission, offer a clearer portrait of 3I Atlas's nucleus, its coma, and its elusive tail, challenging us to reconcile the anomalous with the natural. Here, amid the chemical signatures and luminosity profiles, we seek not just facts but the essence of reality itself, reminding us that the universe reveals its secrets not through whispers of intent, but through the unyielding language of light and matter. The James Webb Space Telescope, humanity's premier infrared observatory launched in 2021, has turned its gaze upon 3I Atlas with unprecedented precision since its discovery on the 1st of July, 2025. Initial observations, conducted on the 6th of August, 2025, utilized the telescope's near-infrared spectrograph and mid-infrared instrument to capture the object's spectral emissions, revealing a coma, a hazy envelope of gas and dust, dominated by carbon dioxide at an outgassing rate of 129 kilograms per second. This data, released by the National Aeronautics and Space Administration on the 7th of August, 2025, marks a pivotal update, as earlier ground-based telescopes like those in the Asteroid Terrestrial Impact Last Alert System network had only hinted at faint activity. The carbon dioxide lines, sharp and prominent in the mid-infrared spectrum, indicate sublimation from the nucleus's surface, where solar heating, albeit weak at 4 astronomical units from the Sun, begins to liberate trapped volatiles. Yet, the anomaly persists. Water vapor, a staple of cometary spectra, registers at a mere 6.6 kilograms per second, with hydroxyl radicals fragments from water dissociation barely detectable. This imbalance, where carbon dioxide overshadows water by a factor of nearly 20, deviates from solar system comets like Hale-Bopp or Hyakutake, which typically exhibit water-dominated outgassing even at greater distances. Complementing these findings, The spectrophotometer for the history of the universe, Epoch of Reionization, and ICE's Explorer mission, launched in 2024, has provided broadband infrared mapping of 3I Atlas since mid-August 2025. Designed to survey galactic dust and ices, spectrophotometer for the history of the universe, Epoch of Reionization, and ICE's Explorer's observations, detailed in a National Aeronautics and Space Administration press release on the 26th of August 2025, confirm a reddish overall spectrum for the object, indicative of organic tholins complex hydrocarbons formed by prolonged exposure to cosmic rays. The mission's data, covering wavelengths from 0.6 to 5.3 micrometers, reveals traces of carbonyl sulfide, a sulfur-bearing molecule rarely prominent in comets, at rates suggesting secondary production from carbon dioxide interactions with cosmic rays or internal chemistry. Notably, the coma appears sunward-oriented, a teardrop-shaped cocoon spanning 24 kilometers around an 11-kilometer nucleus, as refined by combined James Webb Space Telescope and Hubble imagery from the 21st of July, 2025. This orientation, without the expected anti-solar tail elongation from radiation pressure, has puzzled modelers. A study from the University of Maryland, published on Arxiv on the 27th of August, 2025, attributes it to uneven porosity in the nucleus, where gases escape preferentially from sunlit hemispheres. The Hubble Space Telescope, venerable companion to these newer instruments, has contributed visible and ultraviolet data that sharpens our view of the object's luminosity. On the 21st of July, 2025, Hubble's Wide Field Camera 3 captured the steep brightness profile, a slope of -4 that Avi Loeb cites as evidence of self-generated light. Updated photometry from the 25th of August, 2025, via the Interstellar Citizen Science Network, confirms a magnitude of 16.0, with variations suggesting a rotation period of 29 hours. This stability contrasts with Oumuamua's tumbling in 2017, implying a more cohesive structure. However, the absence of cyanogen and diatomic carbon emissions, volatiles that fluoresce in ultraviolet and should appear at this distance, remains conspicuous. The James Webb Space Telescope's mid-infrared instrument, in spectra from the 6th of August, 2025, detects no such lines, supporting the hypothesis of a chemically pristine composition, low in nitrogen and carbon chains, typical of inner solar system comets. These observations coalesce into a portrait of an object aged 3 to 14 billion years, originating from the Milky Way's thick disk, a region of ancient, metal-poor stars. The pristine nature of its ices, devoid of heavy isotopes like deuterium enriched in recycled materials, suggests minimal alteration since formation, perhaps in a carbon-rich protoplanetary disk around a red dwarf star. The dominance of carbon dioxide over water unusual, as water ice forms more readily in most stellar environments, may reflect a birthplace with extreme cold or specific irradiation, where carbon dioxide froze out preferentially. Borisov, the 2019 interstellar comet, showed a similar carbon monoxide bias, hinting at a class of objects from such systems. For 3I Atlas, the spectrophotometer for the history of the universe, Epoch of Reionization and ICE's Explorer, mission's broadband data from the 26th of August, 2025, estimates a nucleus density consistent with porous ice, about 0.5 grams per cubic centimeter, allowing trapped gases to escape unevenly. Yet, the self-generated light hypothesis lingers, fueled by the 10 gigawatt energy estimate. If natural, this could stem from exothermic chemical reactions within the nucleus, where carbon dioxide interacts with silicates or organics, releasing heat that manifests as infrared glow. The James Webb Space Telescope's detection of minimal water vapor supports this, as water would dampen such reactions. Alternatively, radioactive decay from thorium or uranium isotopes, accumulated over billions of years, could provide a steady thermal source, though concentrations would need to be anomalously high. Avi Loeb, in his blog on the 22nd of August, 2025, counters that the frontal luminescence, sunward without pressure, distortion suggests directed emission, perhaps from a plasma sheath or nuclear exhaust. The spectrophotometer for the history of the universe, epoch of reionization and ICES Explorer missions infrared mapping shows no hotspots, but resolution limits at 400 million kilometers constrain detail. Ground-based contributions enrich this dataset. The Very Large Telescope in Chile, observing on the 10th of August, 2025, confirms the faint tail, now extending 25,000 kilometers, with Doppler shifts indicating ejection velocities of 20 to 2,000 meters per second within cometary norms. Amateur networks like Interstellar, reporting on the 25th of August, 2025, note no brightness pulses, ruling out signaling but not internal power. The Russian Academy of Sciences, on the 26th of August, 2025, analyzes spectra as natural, dismissing alien claims. These realities temper speculation. The chemicals skew as environmental, the light as scattered dust. As 3I Atlas nears perihelion on the 29th of October, 2025, further data from the James Webb Space Telescope and spectrophotometer for the history of the universe, epoch of reionization and ICES Explorer, may resolve anomalies, affirming a natural comet or unveiling deeper mysteries. Are we mere observers in a vast, indifferent cosmos, or active participants in a grand dialogue spanning light years? For in the story of 3I Atlas lies not just a tale of science, but a meditation on our identity, our aspirations, and our place among the stars. A reminder that the universe, with its silent expanses, may yet hold companions waiting in the shadows. At the core of these reflections stands the Fermi paradox, that enduring riddle posed by physicist Enrico Fermi in 1950. If the universe is so vast, teeming with billions of stars and potentially habitable planets, where is everybody? 3I Atlas, arriving in our skies on the 1st of July, 2025, sharpens this question like a blade. Our radio signals, spilling into space since the early 20th century, have formed a bubble extending 130 light-years, encompassing countless stellar systems. Have these broadcasts our laughter, our music, our cries of discovery pierced the silence, summoning a response? If 3I Atlas is merely a natural comet, its ancient ices and carbon dioxide-dominant coma, a product of distant stellar birth, it underscores the paradox's cruelty, a universe filled with matter in motion, yet devoid of deliberate contact. But if, as Avi Loeb suggests, its self-generated light and improbable trajectory hint at artificial origins, then the paradox dissolves into a darker truth, the dark forest hypothesis from Liu Cixin's The Three-Body Problem, where civilizations hide, silent and watchful, lest they reveal themselves to predators. In this forest, our signals are not invitations but beacons of vulnerability, and 3I Atlas could be a scout, assessing whether we pose a threat or offer alliance. This contemplation forces us to confront our role. Are we explorers, boldly reaching into the unknown, or preservers, safeguarding our fragile world from the perils of revelation? Humanity's history is one of exploration, from the ancient mariners charting uncharted seas to the Voyager probes launched in 1977, carrying golden records of our sounds and images into the interstellar night. The Arecibo message of 1974, beamed toward the globular cluster M13, embodied this spirit, a deliberate call, encoded with our DNA, our forms, and our solar system's map, trusting in the universe's benevolence. Yet, with 3I Atlas, we glimpse the preserver's caution, the fear that our voices have echoed too loudly, drawing eyes we cannot see. If this object, with its 10 gigawatt glow and carbon dioxide outgassing at 129 kilograms per second, is a probe, it may judge us not as equals but as novices, our radio bubble a child's cry in the dark. The James Webb Space Telescope's revelations, on the 6th of August, 2025, of its pristine chemistry, low in water vapor at 6.6 kilograms per second, rich in carbonyl sulfide, could be the signature of an engineered vessel, its anomalies masking advanced systems, or simply the mark of a billion-year journey through cosmic rays. In this duality lies a philosophical crossroads. As explorers, we embrace the beacon proposals emerging from United Nations discussions in August 2025, a network of space-based transmitters, synchronized by quantum clocks, broadcasting at the hydrogen line of 1,420 MHz to join a galactic conversation. This act affirms our curiosity, our belief that knowledge shared elevates all. Yet, as preservers, we heed the warnings, the risks of permanent visibility, the potential obligations of interstellar citizenship, the chance that withdrawal invites reprisal. The Fermi paradox whispers that silence may be survival. Civilizations might self-destruct before contact or evolve beyond detection, leaving us to ponder empty skies. 3I Atlas, originating from the Milky Way's thick disk 3 to 14 billion years ago, embodies this isolation, a relic traversing voids, untouched by intent, reminding us that time itself is the greatest barrier, with light years delaying any reply. These reflections extend to our soul's quest for meaning. Religious traditions, stirred by 3I Atlas, reinterpret ancient texts. The Vatican's affirmation on the 12th of July, 2025, that extraterrestrial life complements creation. Islamic scholars' parallels to cosmic signs in the Quran, Hindu views of interconnected universes. In Buddhism, it evokes impermanence, a transient visitor mirroring life's fleeting nature. Even in secular philosophy, it echoes Carl Sagan's pale blue dot from 1990, our Earth a mote in cosmic vastness, urging humility. If we have summoned it, our signals from baseball games to planetary radar piercing the dark, then we must reckon with galactic citizenship, preparing generations through education in mathematics and physics, tailored for alien discourse. By 2025, curricula evolve, children learning that their equations might one day bridge stars, fostering a worldview where humanity is not central but part of a tapestry. The future, illuminated by 3I Atlas, promises transformation. The Vera C. Rubin Observatory, scanning skies since early 2025, heralds an era of routine detections, potentially dozens yearly, demystifying interstellar objects and resolving whether anomalies like the self-light and chemical skew are commonplace or exceptional. The European Space Agency's Comet interceptor, launching in 2029, waits in Lagrangian points to chase such visitors, sampling dust and gases for direct analysis. If 3I Atlas inspires beacons, international consortia could emerge, with safeguards ensuring equitable voices, smaller nations contributing research, billionaires funding arrays. Yet, psychological support grows essential. Cosmic counseling, formalized by the American Psychological Association in July 2025, helps integrate this expanded reality, addressing divides where elders cling to isolation, youth embrace connection, and children intuit companionship. In this philosophical musing, 3I Atlas becomes a catalyst for self-definition. We are explorers when we build, preservers when we pause. Perhaps the synthesis lies in mindful engagement, joining the cosmic neighborhood on terms that honor autonomy. The universe, no longer empty but a vast community, challenges us. What kind of neighbors will we be? As our radio bubble expands, and visitors like 3I Atlas arrive, the conversation begun, with accidental chatter evolves into deliberate dialogue. The greatest gift may be this awakening to wonder, to question, to dream under the stars' eternal watch. As we reach the final moments of our cosmic journey through the enigma of 3I Atlas, dear listeners, let us pause under the velvet canopy of the night sky, where the stars seem to whisper their farewells. Here, in the tranquil embrace of the evening, as we bid adieu to 3I Atlas, we look forward to the mysteries yet to unfold, carrying with us the wonder of a universe that is not empty but alive with possibility. Let these final thoughts cradle you into slumber, dear listeners, as we ponder whether we have summoned a cosmic neighbor or merely glimpsed a fragment of the eternal. Until we meet again, let the stars guide your dreams. Our journey began on the 1st of July, 2025, when the Asteroid Terrestrial Impact Last Alert System Telescope in Rio Hurtado, Chile, caught sight of 3I Atlas, a fleeting dot against the starry tapestry of Sagittarius. Named C2025N1, this third interstellar object, following Oumuamua in 2017 and Borisov in 2019, arrived with a hyperbolic orbit, an eccentricity of 6.2, a velocity of 58 to 61 kilometers per second, declaring its origin beyond our sun's grasp, likely from the Milky Way's ancient thick disk, 3 to 14 billion years old. Its path, threading past Mars at 29 million kilometers on the 3rd of October, and reaching perihelion on the 29th of October at 1.4 astronomical units, promised no threat to Earth, passing safely at 1.8 astronomical units in December. Yet, its brightness, registering at magnitude 16.0, and its chemical anomalies, carbon dioxide outgassing at 129 kilograms per second, dwarfing water vapor at 6.6, sparked a firestorm of debate. Was this a natural comet, its reddish tholin-laden surface sculpted by cosmic rays, or, as Avi Loeb proposed, a nuclear-powered probe, emitting 10 gigawatts of self-generated light, its trajectory improbably aligned with our ecliptic plane at a mere 0.2% chance? We traced the historical lineage through Oumuamua's silent cigar-shaped sprint, its non-gravitational acceleration unexplained by visible outgassing, and Borisov's flamboyant cometary display, rich in carbon monoxide, affirming interstellar diversity. 3I Atlas, with its faint tail and teardrop coma, seemed a bridge between these extremes, its carbon dioxide dominance hinting at a carbon-rich stellar birthplace, yet its frontal glow and sparse volatiles fueling speculation of artificial origins. The James Webb Space Telescope and spectrophotometer for the history of the universe, epoch of reionization, and ICES Explorer, in data from the 6th of August, 2025, painted a picture of pristine ICES, low in heavy isotopes, suggesting an ancient relic untouched by solar recycling. Hubble's imagery, refined by the 25th of August, 2025, pegged the nucleus at less than 5.6 kilometers, its stability contrasting Oumuamua's tumble. Yet, Loeb's vision of a crafted vessel, perhaps a dark forest scout from Liu Cixin's The Three-Body Problem, persisted, amplified by the improbability of its planetary flybys, 1 in 20,000 odds, and its solar-hidden perihelion. The societal ripples were profound. Markets faltered, with the Nasdaq dipping 2.5% by the 10th of July, 2025, as fears of technological disruption mingled with helium-3 mining dreams. Cosmic counseling emerged to soothe existential dread, as the Fermi paradox loomed: why the silence if life abounds? Religious interpretations, from the Vatican's embrace to evangelical warnings, reframed ancient texts, while education shifted to prepare youth for galactic dialogue. The proposal for an interstellar beacon, debated in United Nations forums by August 2025, embodied our explorer's spirit, promising to join a cosmic network via hydrogen line broadcasts, yet cautioned preservers, warned of permanent visibility's risks. Conspiracy whispers, from Jeremy Corbell's Big Lie to nanomachine swarms harvesting dust like the vanished disk of TYC8241-2652, stirred unease suggesting earthly or alien agendas. Now, as 3I Atlas races toward its October 29th rendezvous with the Sun, obscured by glare, we stand at a precipice. The Vera C. Rubin Observatory, scanning skies since early 2025, heralds dozens of future detections, transforming rarities into routines. The European Space Agency's Comet interceptor, set for 2029, awaits to chase such visitors, promising direct samples of alien ices. Amateur astronomers, via Unistellar and the Sky Live, track its path, inviting all to witness via JPL Horizons. The latest data, as of the 28th of August, 2025, affirm a natural comet, carbon dioxide-driven, chemically distinct, but anomalies linger. The 10-gigawatt glow and low water vapor teasing possibilities of exotic physics or technology. What have we learned, dear listeners? 3I Atlas is a mirror, reflecting our yearning to connect and our fear of exposure. It asks, are we explorers, casting signals into the void, or preservers, guarding our pale blue dot? The synthesis, emerging in global consensus, is mindful engagement, building beacons with care, joining the cosmic chorus on our terms. The universe, no longer a silent expanse, feels like a neighborhood, its stars potential homes for minds pondering the same mysteries. Our radio bubble, 130 light-years wide, may have summoned this visitor, or it may simply be a cosmic coincidence, a relic adrift since the galaxy's dawn. Either way, it reminds us that our story is but one verse in a grander symphony. As 3I Atlas fades into the darkness by early 2026, its legacy endures not in answers, but in questions that stir our souls. I urge you, dear listeners, to keep exploring. Visit JPL Horizons to track its journey, delve into our archives on Oumuamua and Borisov, and share your thoughts on what neighbors we might become. And as we connect under this vast sky, where are you tuning in from tonight? Maybe a moonlit hillside in Cape Town, a bustling cafe in Sao Paulo, or a quiet attic in Dublin. What time is it there, as you dream of distant stars? If this journey has touched your imagination, I'd be delighted if you'd subscribe to Mystery History for Sleep and ring the bell to stay with us for more cosmic stories. Your presence makes this adventure brighter, so let me know your thoughts. And until we meet again in the darkness, this is Mr. H, wishing you dreams as vast as the stars. Good night.